Okay, so this is lesson part 2A of our study on polynomial functions and their graphs. And the objectives for this lesson is basically you'll be given a polynomial function written in standard form and you want to determine the behavior, the end behavior. You could be given a polynomial that's written in factored form and you wanted to determine the end behavior. And then the third thing we're going to look at is, given the graph of a polynomial function, determine the characteristics of the leading term with regards to the degree of the polynomial and the leading coefficient. Okay, now before we go into the problems, so these are basically some problems we're going to work out. But before you do this, you need to make sure that you did study part 2. So the prerequisite for doing this, part 2A, is to have studied part 2. So one of the things we talked about in part 2 was the end behavior and how to determine the end behavior. And so remember, we had to look at the leading term. So we use the leading term test. It's sometimes called the leading term test or the leading coefficient test. And then we looked at whether on the left side, the far left, whether it went up or down, far right, whether it went up or down, and so on. Okay, so we did talk about the fact that if the degree is even or if the degree is odd. So it's very important, it is very important that you go back and you study part 2. All right, so let's go ahead then and look at some problems dealing with part 2A. So the directions are going to be this. So for the first objective, for the first two objectives, it's going to say this: for each polynomial function, determine the end behavior of the graph. So you will not be given the graph for the first two. You'll be given a polynomial function, and you want to determine the end behavior. All right. So the first one, let's look at this. Number 1, so you have f of x is this polynomial function, 3x to the 4th minus 11x squared. Let's go ahead and move this around. Minus 11x squared plus 2x cubed minus 2x plus 8. All right, so the first thing you want to do, see there's 1, 2, 3, 4, 5. There are 5 terms. If you want to determine the end behavior, only one of those terms you need to look at, and that term is called the leading term. So we need to look at the leading term. So you got to find the leading term. Now remember, the leading term is the term that has the highest exponent. So if you look at this, this term here, the exponent's 4, this is 2, this is 3, this is 1, and the constant that has, if you were to put an x here, there'll be x to the 0 power. So the leading term then would have to be 3x to the 4th. So the leading term is 3x to the 4th. I'm going to denote this as LT for leading term. So the leading term is 3x to the 4th. Okay? Now knowing that, you can now use this information from the previous lesson. All right, so since the degree is even, the degree of this polynomial is 4. So since the degree is even, since the degree of f of x is even, in this case it's 4, okay, then the end behavior, it's either going to point up or it's going to point down. All right, now remember, it points up if, remember, a sub n here is the leading coefficient. If the leading coefficient is positive, it points down if the leading coefficient is negative. Okay? So what we got to do now is look at the leading coefficient. So the leading coefficient is 3. So since the degree of f of x is even and the leading coefficient is positive, leading coefficient is positive. Remember, in this case, it's 3. All right, so that means, all right, so let me go ahead and do this. So this means, so therefore, the end behavior of f of x is this. All right, so that means that since it's even and the coefficient is positive, that means that the left side will be pointing up and the right side will be pointing up. It doesn't matter what's between here. That's not the intent of the idea of end behavior. So it's just what happens on the outside. So remember, with polynomials, the domain's all real numbers. So you have arrows. Remember, it's smooth and continuous, and so you have arrows on both ends. All right? Okay, now here's something else you got to know how to write this. So sometimes the directions will say describe it using this idea, or it may say this. So also we can write it as this. We can write as this. So as x approaches infinity, so that's the right side. So as x gets bigger and bigger and bigger, what's happening to these y values? Well, these y values are getting more positive. So that means that f of x approaches infinity. Then on the left side, so that's the left-hand behavior. So as x approaches negative infinity, f of x, the y values, are approaching positive infinity. So the y values are getting more positive. All right? So this and this mean the same thing. So this part is this one, and the right side is this one. All right? So this is your right side, this is your left side. What's the end behavior on the left side, on the right side? What's the end behavior on the left side? Okay? All right, number two. Number two, let's suppose we had this problem. Oh, and by the way, so here's, I just want to show you the graph. So I'm not going to show you the graphs on all of them, but here's the graph for number one. So this is number one. So see how the graph on the end behavior, and remember you're talking about end behavior, right? So that's the behavior on the ends. So on the left side, the right side. So notice that the graph, so that's the graph we were just looking at. So the graph points up. All right, so as x gets more negative, your y values are becoming more positive. As x becomes more positive, your y values become more positive. Okay? All right, number two. So number two, let's suppose we had this in number two. Let me get this. So number two, let's say we had g of x equals negative 2x to the 6th plus 8x to the 4th minus 3x squared plus 2. All right, so again, we have this polynomial function. This polynomial function has 4 terms. We got to determine the leading term. So the leading term, now remember, the leading term is not necessarily the first term listed. All right, so it's not always the first term. In this case, it is, because that's the term with the larger exponent. So the leading term is the first term listed, but some students get confused, and they always, regardless of what's listed here, they always want to choose the first term. You got to be careful. The leading term is the term with the largest exponent. All right, so that's 4, that's 2, and your constant has degree 0. All right, so that's 6. The largest exponent. So your leading term is negative 2x to the 6th. All right, so that means that the degree of this polynomial, so the degree of g of x is 6, which is even, right? The degree is even. So that means either you're on the ends, either it's pointing up or it's pointing down. All right, so since it's even. Now we got to look at the leading coefficient. So the degree of g of x is 6, that's even, and the leading coefficient is negative 2, which is negative, right? So since the degree is even, and so since the leading coefficient is negative, the ends are pointing down. The arrows are pointing down. All right, so basically you're going to get this. So it's going to look like this. So the end behavior, you're going to say this. End behavior is, you're going to say on the left side it's pointing down, on the right side it's pointing down. Now it's also important because you got to know both how to write it both ways, or you can say this. As x approaches positive infinity, so meaning what's happening on the right side, so as x approaches positive infinity, as x gets more positive, what's happening to these y values? So that means that as x approaches positive infinity, so on your right side, your y values are becoming more negative, so negative infinity. On the left side, your y values, so that's your left side, your y values are becoming more negative. So f of x approaches negative infinity. Oops, did not mean to put that. All right, so that's number 2. Okay, number 3. So let's say number 3, we had this for number 3. So number 3, we have h of x is equal to 6x squared plus 3x to the 5th plus 6x plus 5x cubed. All right, so number 3. So 6x squared plus 3x to the 5th plus 6x plus 5x cubed. So we have 4 terms. And so if I want to find the end behavior, if I want to find what's happening on the outsides of the graph of this function, then I have to determine the leading term. So the leading term is going to equal, now here's the question, is 6x squared the leading term? The answer is no, because remember the leading term is a term with the larger exponent. So that, and when I say the larger exponent, I mean the larger exponent of the variable x. So that's 5. So the leading term then would be 3x to the 5th. So that's your leading term. Okay, now since I found the leading term, since you know the leading term is 3x to the 5th, I know this now. So I know that the degree of h of x is odd, because it's 5. So it's 5, right? So that's odd. Okay? So since it's odd, remember what that means. That means that since it's odd, both ends are in opposite directions. So either on the left is pointing down, on the right's pointing up, or on the left is pointing up, on the right's pointing down. So remember, opposite directions if it's odd. So that's what that means. Now, the leading term is 3. Okay, so the degree of h of x is 5, so that's odd. And the leading coefficient is 3, and that's positive. All right, so what that means then is this. So therefore, the end behavior of h of x is this. All right, so since your coefficient's positive, that means that on the left is pointing down, on the right's pointing up. So you're going to say this. So you're going to say either this, you're going to say this, okay, which also means this. So you got to know how to write it both ways. Or you can say, as x approaches infinity, f of x approaches. All right, so what that means is this. So as on the right side, remember, as x approaches infinity, so as x approaches infinity, that's the right side. So as x approaches infinity, what's happening to the y values? Well, my y values are getting larger, more positive. And on the left side, as x approaches negative infinity, so as x gets more negative, what's happening to these y values? Well, the y values are approaching, remember f of x is y, so the y values are approaching negative infinity. Okay? All right, number 4. So let's suppose in number 4, I have, let's see, I have this. So f of x is, so let's say f of x is 3x squared minus 4x plus 12 minus x cubed. All right, so I have this polynomial function. All right, so first of all, we got to determine the leading term. So the leading term is equal to what? So you remember the one with the larger exponent for the variable. So that's going to be this one. Now you got to be careful. Some students will say x cubed, but it's not x cubed. It's a negative x cubed. Okay? It's a negative x cubed. Which, and you got to be even more careful because the coefficient's actually negative 1x cubed, right? All right, so remember that. So negative x cubed means the same thing as negative 1 times x cubed. Okay, now let's talk about, since we know the leading term now, let's talk about the degree. So the degree of f of x is 3, so that's odd. Okay, and now we got to talk about the leading coefficient. And the leading coefficient is -1, so that's negative, right? All right. So since, now remember, if the degree is odd and the leading coefficient is positive, on the left side it goes down, on the right side it goes up. If the leading coefficient is negative, on the right side it goes up, on the left side it goes on the left side it goes up, on the right side it goes down. Okay? So therefore the end behavior of f of x is, and you would say this. So you'd say remember it's negative, so you're going to say on the right side it goes up, on the left side it goes up, on the right side it goes down. All right, you also need to know this. You need to also know this. So that means as x, so let's look on the, so x approaches infinity means what's happening on the right side. So on the right side, what's happening to these y values? Well, the y values are approaching, are getting more negative. So that means that f of x is approaching negative infinity. Now let's look on the left side. So that means this. So as x approaches negative infinity, so that means the left side, what's happening to these y values? Well, these y values, so f of x, is approaching, so remember that it's pointing up, so that means your y values are getting more positive. All right, and I have a graph for this. So let's look at this graph. So here's the graph of, I'll make sure I get the right one for you. So the graph of number 4. So here's the graph of number 4. So you see what it looks like? So on the left side, it's pointing up. On the right side, it's pointing down. So again, that means that as x gets on the right side, as x gets bigger and bigger and bigger, your y values are becoming more negative. On the left side, so if you look on the left side, so on the left side, as x gets more negative, what's happening to these y values? Well, your y values are becoming more positive. Okay? All right, so that's what we found. Okay, number 5. So let's do number 5. So number 5, let's say we had this in number 5. Okay, so number 5, we have g of x is 2x minus 3 times x minus 4 times x plus 1 times x squared minus 4. Okay? Now, the difference, I want you to notice this, the difference between the first 4 is that in the first 4, your polynomial was written term by term. Okay? Now, sometimes it was in standard form. Now, standard form, when we say standard form, it means it's term by term in descending order. They weren't always in descending order, but at least it was written term by term. And those were easy to deal with. Here, though, this is in factored form. Okay, so again, it's very important. It is very important you go back to the previous lesson, lesson 2. Okay, so lesson 2, to review that part as well. All right, so we're going to kind of talk about it, but the understanding is very important. You go back and understand, well, why is it that in factored form we're doing it this way? Okay? All right, so let's look at number 5. So remember in our previous lesson, meaning part 2, when we talked about this in part 2, we saw this. If it's in factored form, the leading term you will get by taking the leading term of each factor. So the leading term of g of x will equal the product. Remember, these are all products, right? 2x minus 3 times x minus 4 times x plus 1 times x squared minus 4. So you're going to take the leading term of each factor. So the leading term of this factor is 2x. Now remember, the leading term is the term with the larger exponent for the variable. And then over here, the leading term is x, so times x. The leading term here is x. And in the last factor, the leading term is x squared. Okay? And so you just multiply that out. So 2x times x times x times x squared will be 2x to the 1, 2, 3, 4, 5, to the 5th power, right? So we found the leading term. Once you find the leading term, then you go back and you do it just like we did the previous 4 problems. Okay, so once you find the leading term, then you say this. Since the degree of g of x is 5, which is odd, okay, and the leading coefficient is 2, which is positive. Okay, so remember, if the degree is odd and the leading coefficient is positive, remember that means this. That means on the left side, remember the arrows, since it's odd, the arrows point in opposite directions. So on the left side, it points down. On the right side, it points up. Okay, so you would say so the in behavior of g of x is, and then just rewrite this. So on the left side it does this, on the right side it does this. Also, you need to know how to write it the other way. So that means that as x approaches infinity, so meaning what's happening on the right side, so on the right side, what are your y values doing? Well, the y values are getting more positive. See, on this side it's pointing left, so on the left side it's pointing down, excuse me, on the left side it's pointing down. So that means that as x approaches negative infinity, so meaning the left side, what's happening to your y values? Well, your y values are approaching negative infinity. Okay? And I have a graph for number 5. I can quickly get it. So number 5, I think this is it. Yeah, this is it. So here's number 5. See what it looks like? So on the left side, it's pointing down. On the right side, it's pointing up. So that's the graph of this one. All right. Now, again, it doesn't matter. It doesn't matter what's happening inside. It doesn't matter. That's not our intent here. The intent here is to determine just what's happening on the outsides. On the left side, on the right side. So on the left side, it's pointing down. On the right side, it's pointing up. Okay? And that's what we're saying here. So on the left side, here's the left side. Left side is pointing down. Y's are becoming more negative. So your y values are becoming more negative. On the right side, your y values are becoming more positive. Okay, number 6. So number 6, let's suppose we had this one. You had k of x is equal to x squared times 3x minus 2 times 2x plus 1. So again, it's in factored form. So we got to first of all find the leading term. Remember, to find the leading term of k of x, we take the leading term of each factor. Now you see over here, this factor right here is x, and it occurs twice. So we got to use both of those. So we got to say x squared. All right. Now here, the leading term is a binomial. So I'm sorry, the factor is a binomial. So the leading term is going to be 3x. So I'm going to say times 3x. And then over here, this factor, the leading term is 2x. And so I'll multiply this out. So the leading term is going to be 6, 3 times 2 is 6. X squared times x is x to the 4th. So there's your leading term. All right, easy to do, not difficult. And so remember, to determine the in behavior, all you need is a leading term. That's all you need. Okay, so when doing these, if they're asking to find the leading term, don't multiply all this out. Don't multiply all those terms out. You just need to find the leading term, and that's how you find the leading term. You take the leading term of each factor. So here now this is a monomial. These are binomials. So the factor here is x, but remember x squared means x times x, so I got to use it. Here, this binomial, the leading term is 3x, and then here the leading term is 2x. Okay? And so once I know that, then I can say this. Since the degree of k of x is 4, which is even. So remember, if it's even, it points in the same direction. Either it's pointing up or it's pointing down. Okay? And since the leading coefficient is 6, which is positive, then that means, so therefore, the end behavior of k of x is this. So since it's even, it points in the same direction, coefficient's positive. Now when I say it's even, I mean the degree. And the leading coefficient is positive, it means that they're both pointing up on both sides. All right, so that means this. So as x approaches infinity, so meaning on the right side, as x gets more positive, your y values are getting more positive. On the left side, as x approaches negative infinity, so as x gets more negative, your y values are getting more positive. All right, so that's number 6. So you're done with number 6. Now number 7. So number 7, let's suppose we had this in number 7. Number 7, let's suppose we had f of x is negative 2 times 3x minus 4 times x squared plus 2 times x squared minus 1. Okay, so let's suppose we had that. All right, so those are in factored form. Now again, remember that I can further factor x minus 1, and I will, just to show you something. But I don't need to. I don't have to factor x squared minus 1, because remember that's the difference of two squares. I can leave it like that. I'm good leaving it like that. So we can easily find the leading term. So remember though, the leading term, you got to use every factor you see. The leading term, you got to look at every factor you see, and you got to choose that leading term. So if I look at, let's start with this one. Now this is a factor. I'm going to come back to this. Let's look at this one. So in this factor right here, what's the leading term? Well, the leading term is 3x. Times, in this factor, what's the leading term? Well, the leading term is x squared. And over here in this factor, what's the leading term? Well, the leading term is x squared. If I go here, this factor, that's a constant, so I got to use it still. Even though there's no variable attached to it, it's a constant, and that's the only thing I see in this factor, so I got to use it. All right, so you got to look at all these factors. Every one. So every one you underline, everything you underline, you got to have something coming from it. Okay? All right, and so we just multiply that out. So negative 2 times 3 is negative 6, and then x times x squared is x to the 5th. All right? Now, before I go on, I want to show you something. You see here, I could have factored this as x minus 1 times x plus 1. And so instead of listing 4 of these like this, I can have said this, or you could have said negative 2 times 3x times x squared, and then let's use this times, what's the leading term over here? Times x. What's the leading term over here? X as well. But isn't x times x x squared? Okay, so even though you can see you can factor it further, you don't have to. You just take the leading term that's there. Okay. All right, so you get the same thing. You get negative 6x to the 5th. All right, so now I can determine the end behavior. So since the degree of f of x is 5, which is odd, so that means that since it's odd, they're pointing in opposite directions. And let's look at the leading term now. And the leading term, I'm sorry, I didn't mean the leading term, I mean leading coefficient. And the leading coefficient is negative 6. So that's negative, right? So that's negative. Then that means, remember it's negative, the leading coefficient is negative. So that means the end behavior of f of x is, so that means on the left side, it's pointing up. On the right side, it's pointing down. Or you can say this, as x approaches infinity, so on the right side, what's happening? So here's your right side, here's your left side. So on the right side, it's pointing down. So your y value is becoming more negative. And on the left side, so as x approaches negative infinity, on the left side, your y value is becoming more positive. So if x approaches infinity. And I have a graph for this one. So here's the graph. If I can quickly get it. Here's the graph for what we just did. See how it looks? So there's the graph. So here's the left behavior. Here's the right behavior. I don't care what's happening here. Okay, that's not the intent of this part of our lessons. I just want to know what's the end behavior. All right, so on the left side, you see as x approaches negative infinity, what's happened to your y values? Well, your y values are becoming more positive. Over here, as x approaches positive infinity, so as x gets larger and larger and larger, your y values are getting more negative. And that's what we just said. Okay, so see left side, right side. All right, so that's number 7. Okay, number 8. So number 8, let's say we had this. So number 8, we have h of x is x plus 1 cubed times 3x minus 1 times 2x plus 5 squared. All right, so x plus 1 cubed times 3x minus 1 times 2x plus 5 squared. Okay, now, when finding, remember these are in factored form, so h of x listed as factors. So we got to find the leading term. So the leading term, remember you look at each factor. See, now this factor is x plus 1, right? What's the leading term? The leading term is x. But how many times does x plus 1 occur? Well, x plus 1 occurs 3 times. So this is really x to what power? The third. Because remember, let me go ahead and write it right here. So remember, what we have is this. So y'all agree that this right here is the same thing as saying this. X plus 1 times x plus 1 times x plus 1. X plus 1 cubed. And then times 3x minus 1. And then here, this factor occurs how many times? 2 times. So that's 2x plus 5 times 2x plus 5. Y'all agree? Okay. So you don't have to do all this, but in your mind, that's what you're looking at. You're looking at the fact, hey, x plus 1 is occurring 3 times. So since the leading term is x, I've got to actually say x times x times x, which is x cubed. Okay? And then over here, that's just 3x minus 1, and that occurs how many times? Just 1. So that's just 3x, and then times, and then the same thing here. My leading term is 2x, but this factor occurs how many times? Remember, it occurs 2 times, so it's 2x times 2x. So you got to say twice, just like this. All right? And now we're going to multiply this out. So the leading term of h of x is 3 times 2 times 2. That's what, 12? That's 12. And then x cubed times x times x times x, so that's x to the 6. All right? So that's your leading term. Very simple, not difficult to deal with. Now let's talk about the end behavior. So we got to find the leading term first. So remember, we multiply because these are factors. So these factors are listed as products. All right, now remember, the whole idea is not, in fact, you would not want to multiply all this out. You would not want to expand this. So don't expand this to find the leading term. You just look at the leading term of each factor. Okay? All right, so the degree of h of x is 6, so that's even. So when we talk about degree, we talk about even or odd. Remember that? Even or odd. So when we talk about degree, you're looking at even or odd. Is the leading coefficient where you look at positive or negative. All right, and remember this is from the previous lesson, so it's important you go back and review this. All right, so since the degree of h of x is 6, that's even, and the leading coefficient is 12, which is positive, that means that the end behavior of h of x is, and remember, even, same direction, odd, opposite direction. So since it's even, same direction, and positive, they're both pointing up. So on the left side, it points up. On the right side, it points up. And so you would also say this, or you can say, and you need to do this because you'll be asked to write this in several ways. So you can say, or on the right side, as x approaches infinity, what's happened to those y values? Well, they're getting more positive. So your y value, f of x, approaches infinity. On the left side, as x approaches negative infinity, what's happened to those y values? Those y values are approaching positive infinity. All right, so that's number 8. Okay, number 9. Let's go to number 9. Number 9, let's suppose we had this in number 9. So we have number 9, we have 3x times 2x minus 3 squared times 4x minus 1. Oops, and if I'm sorry, that's k of x. K of x equals this. So that's your polynomial function, k of x. All right, so this listed as factors. So we got to find the leading term of k of x. So we got to look at every factor. Now, most students understand that this is a factor for x minus 1. Most students understand now that 2x minus 3 is a factor occurring 2 times. Now, for 3x, you got to understand that 3 is a factor and x is a factor. So each of those is a factor in itself. Okay? So you see how I have 4 things underlined? All right? So I need to make sure I take care of each of those 4 factors. All right, so my first one's 3. I have to use it. That's a monomial. So you always list your monomial factors. Here's an x. I got to list it. Now over here, though, that's a binomial factor, but it occurs twice. So that means that this leading term, remember, this really means this is number 8. This is number 9. So that really means that k of x is really 3 times x times 2x minus 3 times 2x minus 3, right? Times 4x minus 1. Okay, so it's really 1, 2, 3, 4, 5 factors. And so I have my 3, I have my x, I have my 2x, and then here's another 2x, and then here's my 4x. So those are your leading terms. So I got to say 2x, and 2x is occurring how many times? Twice. And then in this factor, your leading term is 4x. All right, and you just multiply it out. So 3 times 2 times 2 times 4. So 3 times 2 is 6. 6 times 2 is 12. 12 times 4 is 48. So I got 48. And then x times x times x times x is x to the 4th. All right, and so I get this. I get, since the degree of k of x is 4, which is even. Okay, since the degree is even. And now we got to look at the leading coefficient. So we determine in behavior, you need to know the degree and the sign of the leading coefficient. And the leading coefficient, which is 48, which is positive. So since the leading coefficient is positive, then the end behavior of k of x is, and they're pointing in the same direction, positive meaning up. So that's what we get. Or you can say, again, as x approaches infinity on the right side, my y values become more positive. As x approaches negative infinity, so this is the left side. So on the left side, as x gets more negative, your y values are getting more positive. All right, so that's number 9. Okay, so what we have at this point is this now. So if I go back to the previous, if I can find it. So our previous directions, remember, was this. Okay, so our previous objectives, so we did the first 2. So we looked at the end behavior if the polynomial is written term by term, and if the polynomial is listed as factors. Now let's look at number 3. So number 3, what's going to happen is this. So you're going to be given, in number 3, objective 3, you'll be given a graph, and remember these are smooth and continuous. Smooth and continuous, arrows on both ends, so that's a polynomial function. So these are all polynomial functions we're dealing with. And so for each graph of the polynomial function, determine the degree of the polynomial and the sign of the leading coefficient. All right, so basically if you were to look at the leading term, in terms of the leading term, what will be the exponent of the variable and what would be the sign of the coefficient. All right, so the degree, now remember, if it's in opposite directions, what does that mean? It means the degree is odd. So automatically we know the degree is odd. So the answer, you're going to say this. The degree, for part A, the degree is odd. All right, now if it points points down on the left, points up on the right, that means the leading coefficient is positive. The leading coefficient is positive. All right, number two. Number two, notice the end behavior. So the behaviors on the ends. So right here, they're both pointing up. So that means the degree is even. So here, the degree is even. All right. Now we don't know what it is. We just know it's even, and that's fine. That's all you want to know here. The degree is even. You can't tell from here what it actually is. All right. All we know is that it's even. In part B, you want to find the sign of the leading coefficient. So since they're both pointing up, that means the leading coefficient is positive. Leading coefficient is positive. All right. Number three. Here, what's the degree? The degree of the polynomial? Well, since they're both pointing in opposite directions, the end behavior, this one's going up, this one's going down, that means the degree is odd. All right, now, let's talk about determine whether the leading coefficient is positive or negative. Well, if it's odd, remember, if it's pointing up on the left, pointing down on the right, that means the leading coefficient is negative. So the leading coefficient is negative. All right, and then finally, number four. Here's number four. So again, the arrows are both pointing down, so that means the degree is even. The degree is even. And B, the sign of the leading coefficient. So since it's pointing down, that means the leading coefficient is negative. Okay? And so that is part 2A. So in part 2A was a continuation of part 2. So it was very important. It was very important before we do part 2A that you go back and look at part 2. And that's the end of this part of our lesson.